Hawaii, one of the most isolated and geographically diverse regions on our planet, is also home to one of the most diverse and unique research and educational institutions in the world. The University of Hawaii is a dynamic hub of innovation, exploration, and research in the middle of the Pacific Ocean. The original Polynesian seafarers who discovered and made these islands their home relied in part on their knowledge of stars and constellations in their exploration of the world around them. That tradition of discovery continues today with the world-renowned work being done in astronomy and space exploration. With high volcanic peaks and clear skies offering ideal sites for observing the stars, the University of Hawaii provides cutting-edge facilities to astronomers from around the world. Dr. Ken Chambers is the director of the Pan-STARRS observatories. As part of a team mapping large-scale matter distribution in the universe, Pan-STARRS has partnered with the international scientific community to detect near-Earth objects that could potentially threaten our planet.
We know that the Earth has been impacted before. The end of the Cretaceous period that wiped out the dinosaurs was from an asteroid. So the odds are very, very low that in our lifetime anything will happen. But the risk is very, very high, and so it's prudent to search for these. So we have several programs at IFA. Pan-STARRS is right at the level where we can take the best use of the very good atmospheric seeing on Haleakala. It's unusual for a telescope. It's more like a really large camera than what people traditionally think of a telescope. And its optics are designed to take a very large field of view so that you can get as much of the sky in one picture at a time. So it produces this movie of the night sky. And in particular, that's very good for finding near-Earth asteroids, moving objects in the solar system. There's just been hundreds of discoveries that Pan-STARRS has made over the years that are changing the way we think about the universe. The value of surveying the sky over and over and over again turns out to be greater than we even imagined when we started out. And people just need to take the time to sit and search through it. And that's what the astronomical community is doing now. They're downloading our data like crazy because it's a lot of data and doing their own searches for it. And that's fantastic. It's wonderful to have the whole world using our data for all kinds of things that we can't imagine and would never have thought of.
Sometimes man's quest for knowledge means physically traveling into the unknown. But exploration is not without hazards. To learn more about the dangers posed by long-duration space explorations, Dr. Veronica Bindi and her team collect, analyze, and interpret data from the Alpha Magnetic Spectrometer, or AMS-2, a state-of-the-art particle physics detector on board the International Space Station, in their quest to better understand cosmic rays and space radiation and their effects on humans.
These particles that they shoot into our universe, we can measure them, and so we can see from the abundance of the different elements the life of the stars. We can study if all the universe is made of matter or maybe is made of antimatter. We can study also if there are exotic particles, exotic elements in the universe that are not present in our Earth. So this is very fascinating to understand the evolution of our galaxy, the evolution of our universe, because from the proportion of this matter, we can really understand how our universe is evolving. I was approached by NASA, and they were like, this data that you are collecting on the top of the atmosphere are very important for our astronauts, because you know that this International Space Station is the house of the astronauts somehow when they are out there. And these particles that are so important for us, in the reality, for astronauts may be detrimental because, you know, you might have some damaging in the DNA. That is one of the major reasons why we still haven't sent humans to Mars. So they were really interested in this topic, and we started the collaboration. So we are providing all this important information to them. We are collaborating with them to make new shieldings for new spacecraft going to the Moon and to Mars.
While exploration of the red planet has become the next giant step for mankind, our own sun still holds many of its own mysteries, secrets, and dangers. Dr. Jeff Kuhn has developed new concepts for solar telescope instrumentation in order to better understand the outer layer of the sun's atmosphere and the tremendous amount of energy stored there, so that solar events and their often disruptive effects on the Earth can be mitigated.
There are clear examples in the history of the sun where the destructive force of a solar flare was enough to burn telegraph stations to the ground because of the electromagnetic pulse. Well, the modern equivalent of that for much less energetic events is the destruction or the blinding of our technology in space that we depend on, especially in Hawaii. Once you move out into the atmosphere of the sun, most of the energy is locked up in the magnetic field. So the energy, which ultimately is what affects the Earth through explosions, we call them flares, that energy is contained in the magnetic field, and we're never going to understand how that energy is released unless we can measure that magnetic field. When the DKIS telescope comes online, it represents the biggest jump in our ability to understand and measure the properties of the sun since Galileo. It's an enormous jump, and it's one which the rest of the world community is already lined up to be able to have access to this telescope. It's a testament to the project that the best people in the world are interested in coming to Hawaii to be a part of this adventure.
From studying the smallest particles to the largest celestial objects and beyond, University of Hawaii researchers are finding new ways to understand the universe around us. Research and innovation at the University of Hawaii. From distant galaxies to the ocean depths and everywhere in between.